Okay, so for this video, we're going to be looking at 2017 FRQ number 5. Okay? All right, so two particles move along the x-axis. For t between 0 and 8, the position of particle P at time t is given by x sub p. So that's the position of P of t at the equals the natural log of t squared minus 2t plus 10. While the velocity of particle q at time t is given by v sub q, so the velocity of q of t equaling t squared minus 8t plus 15. Particle q is at position x equals 5 at time t equals 0. For part A, for t between 0 and 8, when is the particle p moving to the left? So do you remember when a particle is moving to the left? Okay, so for a particle to move to the left, what we're going to do is we are going to take the derivative. Okay, so for p, we were given the position function. So in order to figure out when we're moving to the left, we need to know when the velocity is negative. All right, so let's go ahead and take the derivative of the position function. So x of p of t is the natural log of t squared minus 2t plus 10. And now for the derivative, so the velocity of p. The bottom, the derivative for a natural log, it will go to the bottom, and then its derivative will go on top. So the derivative of t squared is 2t, the derivative of minus 2 is of negative 2t is just minus 2, and the derivative of 10 is 0. So what we need to do is we need to figure out when this velocity is less than 0. One way we can do that is a sign chart. Okay, so we can look at the top and we can look at the bottom. For the top, if I set that equal to 0, t is going to equal 1. And now for my time interval, remember this is only between 0 and 8. So between 0 and 8, 1 for the top. Anything bigger will be positive. Anything smaller would be negative. For the other part, t squared minus t plus 10, I try and think of a way to maybe try and factor it, but there aren't any numbers that would multiply to get 10 and add to get negative 2. So instead what I want to do is maybe try the quadratic formula. Okay, so the opposite of b plus or minus square root b squared minus 4 times 1 times 10 all over 2 times a. So 2 plus or minus square root 4 minus 40 over 2. Because the inside is negative, there are no real solutions. Because there's no real solutions, there's nothing that would make that equal to 0. Okay, so this is going to be positive everywhere. All right, so my velocity is negative between 0 and 1. It's positive between 1 and 8. So the particle, so P, is moving to the left on 0 to 1 because the velocity of P is less than 0. Okay? Okay, so let's take a look at part B. For t between 0 and 8, find all times t during which the two particles travel in the same direction. So we already know when p is traveling to the left and to the right. So the other thing I need to look at is for q. Okay? So for q, the velocity function is given by t squared minus 8t plus 15. That one's already velocity, so that's kind of nice. All we need to do on this one is just factor it and make a sign chart. So t squared minus 8t plus 15. Let's go ahead and factor it. And then let's set them equal to 0. So t equals 3 and t equals 5. And then let's make a sign chart for this. So between 0 and 8, and 3 and 5 are my two places where I have zeros. So t minus 3, t minus 5. Anything bigger than 3 would be positive. Anything smaller would be negative. If you plugged in a number bigger than 3, let's say like 4, t minus 3 would be positive. If you plug in a number smaller, like 0, you're going to be negative. And the same goes for 5. If we try and plug in something bigger, we're going to get something positive. If you plug in something smaller, you're going to get something negative. So for Q, between 0 and 3, if I take a negative times a negative, I get a positive. Between 3 and 5, a positive times a negative would be negative. And between 5 and 8, positive times positive is positive. Okay? So what I'm going to do is I'm going to look at these two sign charts. I'm going to have one for P and one for Q. I have 0 and 8 as my endpoints. I have 1 for Q, or for particle P, that's what we started with. I'm going to kind of take the two separate sign charts and kind of put them together so we can see them both at the same time. Okay? So for P, at 1, I changed signs, so I was positive, then negative. And then for Q, between 3 and 5, I was negative. And I'm positive on either side. So I want to know when they both have the same sign, right? So it says, when are they traveling in the same direction? Between 0 and 1, particle P is moving to the left, Q is moving to the right. On 1 to 3, P is moving in the positive direction, Q is moving in the positive direction because they are both positive. Between 3 and 5, particle P is moving to the right, Q is moving to the left because one's positive and one's negative. And then between 5 and 8, they're both positive again, so they're both moving in the right direction, or to the positive direction. They're both moving to the right. Okay? So I would say both particles are moving to the right. On 1 to 3. And 5 to 8, because the velocity of P is greater than 0 and the velocity of Q is greater than 0 on these intervals. Okay? All right. Any questions on that one? No? Okay. Okay. Let's try part C. Find the acceleration of particle Q at time t equals 2. Is the speed of the particle increasing, decreasing, or neither at t equal 2? Explain your reasoning. So for part C, I want to know, well, first it says find the acceleration, right? Yep, find the acceleration of particle Q at time t equal 2. So the velocity of Q is t squared minus 8t plus 15. Its derivative, the acceleration, the derivative of t squared would be 2t, the derivative of minus 8t would be negative 8, and then plus 15 would be the derivative of 0. It says find the acceleration of particle Q at time t equals 2, so we're going to go ahead and plug in 2. So 4 minus 8 is negative 4, okay? So the acceleration, oops, is negative, okay? And then it says, is the speed of the particle Q increasing or decreasing at time t equals 2? So to determine whether a particle is increasing or decreasing in speed, what we need to look at are the signs of both acceleration and velocity. So let's figure out whether the velocity at 2 is positive or negative. I don't care about the actual value. All that matters is it positive or is it negative? Okay, so let's look at the sign chart here for Q. 2 would be between 0 and 3, where the velocity of Q is positive. So this velocity is greater than 0. Okay. Because my signs are different, because the signs of the acceleration and velocity are different, one's positive, one's negative, the speed is decreasing. So I would say this at t equals 2, the speed of Q is decreasing because acceleration is less than 0 and the velocity of 2 is greater than 0. Okay? Okay. Part D. Find the position of particle Q the first time it changes direction. So if we go back to part B, the first times it changes direction would be the first time it changes sign. Okay? And that would be at t equals 3. So I would say Q first changes direction at t equals 3 because the velocity changes sign. And so now to find the position, to figure out the position at t equals 3, we were given one of the initial places. Oops. So we were given its initial position at time t equals 0. My position is 5. But now I need to find the position at t equals 3. So what I'm going to do is I'm going to take the integral of velocity. And now remember, if I take the integral of velocity, I'm going to end up with a position function. And I'm going to go from the initial to the new. So my initial was at time t equals 0. And my new time is at t equals 3. Okay? So I'm going to evaluate the position from 0 to 3. So the integral from 0 to 3 of the velocity, I'll plug that function in here in just a second, but the position at 3 minus the position at 0. Let's plug in the things that we know. We know the velocity function for Q. The velocity for Q was t squared minus 8t plus 15. I don't know the position at 3, but I do know that the position at 0 was 5. Okay. I want to solve for the position at 3, so I'm going to go ahead and move the 5 over. And now what we're going to do is take an antiderivative of that integral. We need to solve the integral. All right? So let's see here. We're going to add 1 to the power, divide by the new power, minus add 1 to the power, divide by the new power, plus add on a variable. Okay? Okay, so this is 5 plus all of that. 5 plus 1/3 3 cubed minus 4 times 3 squared plus 15 times 3. If you plugged in 0 for any of that, you would just get 0, so that would go away. So let's see here. 5 plus 3 cubed is 27, divided by 3 is 9, minus 3 squared is 9, times 4 is negative 36, 15 times 3 is 45. 5 and 9 is 14, 36 plus, negative 36 plus 45 is 9, so this would be 23. So the position of the particle at t equals 3 is 23. Okay? All right, let's talk about scoring real quick. As far as points are concerned, for part A, you would get 1 point for the derivative function, and you would get 1 point for your interval. Okay. For part B, you would get 1 point for the intervals, and then 1 point for your analysis using the velocity and using the different velocities. If you only have one interval with analysis, you just get 1 out of 2. If you don't have any kind of analysis, any kind of reasoning through it, then you would get no points. Okay. And the analysis, the sign charts don't count for points, but having like this kind of work and having your justifications, I feel like would be sufficient. Okay. For part C, finding the acceleration at 2 would be a point, and then 1 point for the speed with reason, whether the speed is increasing or decreasing with your reason. For part D, you'd have 1 point for your antiderivative, you'd have 1 point for using the initial condition, and you'd have 1 point for your answer. Okay? All right.